I'm ready.
Yeah, I'm ready to.
Perfect. Very good. So let's go after this week lab. And this week, I'm going to talk about concrete placement uh, vibrating operations. So vibrating is for reducing the amount of the air inside the concrete, so it can make it dense, more dense. So in this case, we have to move the concrete fast, then the air can get out. But not any type of vibration is good. The size of the vibrator is important. It's the diameter of this is very important for what kind of concrete you want to actually vibrate. The thickness of the element, all these stuff are important. The angle that you are pushing this inside, the spacing, based on the chart for each vibrator, the effective zone around this is in the catalog. For example, for this one is about maybe 6 inches. So every 6 inches, you have to go with vibration. Otherwise, you cannot make overlap with the concrete. You will lose some part with no actually vibration. So those are important. If the angle, if they put them with 30-degree, that's not good. It can actually remove the air. It should be almost close to 45-degree uh, for the angle to make sure that the air can get out correctly. So those are very important part for this case. And sometimes they can carry, the labor can carry it by itself when it's a small. For big construction like a bridge, this is a picture from the bridge deck concrete pour. And in that case, they are bringing few of this. Is not just one guy, because that's a lot of concrete. They have 3 or 4 guys they are doing at the same time behind the bead wall when they pour concrete, and they are using this vibration behind the system. And because that's heavy, so they have a generator, they connect that to generator, and with somebody is moving the generator, most of the time they are putting that on top of that bead wall. Bead wall is a machine that actually make it smooth transversely. So if you like to work on that, but please let me know. I can give you some pictures for that kind of structures for the bridges. So this guy is just carrying this uh, part of the uh, vibrator. Is heavy and hard to hold it for a long time, because they have to work sometimes 10 or 12 hours. So it at the end should be very stressful and hard. Sometimes there is no room because you have a lot of rebar in retaining walls most of the time. Sometimes the car, when you have steel profile plus rebar around that, so in that case you have a lot of rebar. If you send the vibrator inside, you can't pull that out. So it's very limited space inside. So in that case, we are using vibration just connected to the form. So it can just vibrate the form. And they are not going to pour the concrete all the way to the top of the form. At first, the form is not designed with that kind of pressure. They have to go slowly for every 2 to 4 feet maximum. 2 feet or 4 feet maximum concrete, stop it and vibrate this completely, and then wait a little bit to this part gets a little hard, then pour on the second part. If they keep going, the whole form will be exploded. Just be careful. It happened for those that they were not actually expert in concrete placement. So the labor, the foreman, if they're not that expert, they can actually make huge problem in the field. As you can see, these are the vibrators that they installed on the form. And with vibrating this, it can transfer the vibration to the form, and the form to the concrete. It's not for that thick walls. If the wall is 2 feet thick, for sure it's not using. They can use that because it can vibrate for about 6 or 8 inches maximum. So if it's 2 feet, 8 inch from that side, 8 inch, you have some at the middle that is will not get any vibration. It's not acceptable. So these are for limited thickness, and because of that, there is no room for vibrator actually send it inside because the thickness is limited. Otherwise, you can use the regular vibrator.
Professor?
Yes.
What is this? What is this slide about concrete placement? I kind of missed the beginning of the lecture.
Look at this. Show something where this is. Let me see if I have something. Okay.
What's the name of it at the top of the slide?
This slide.
Yeah.
Concrete placement, vibrating operations.
Oh, okay, thank you.
Okay, so imagine if you have a, no, I don't want this, I want this one. Okay, imagine you have a wall like this, yeah, retaining wall, that's a cross section. And you have lots of rebar, yeah, you have rebar and where is the pen? I missed the pen. Actually, okay, so imagine we have lots of rebar here, yeah, rebar here, and rebar this side, okay, and then because the thickness of this wall, this is a plan view, is not that big. Imagine you have 8 inches. You have 2 curtains of rebar. So there is no room between these two to send the vibrator inside. And that's a tall wall. Yeah. So there is no room. If you send it, it will go between the rebar and you cannot pull them back. I heard that they send actually those vibrators inside, they couldn't pull them back. And at the end, they had to cut it. Just leave it there. So it can happen. So if it's not a thick wall and you don't have enough space to send the vibrator between these 2 layers of the rebar inside the wall for vibration, so in that case, this operation is the best because it's not thick. If you install one vibrator here, another vibrator here, so the arrangement should be based on the catalog and the spacing based on the power of these vibrators. So it will go all the way to this side, this wall will go all the way to that side, and they have overlap, so you will get good vibration for this system. Did I give you the answer?
Yeah.
Okay. So let's go to the next one. If the same vibrator, as you can see, some of them, they can carry those and they are installing and pushing, holding over here for a few minutes, and then the other side. It's not that good because somebody should be there to watch the operation to see, because if it's tired, just doing this side, then that side, this side is not that good. And the column is very actually element that will carry a lot of load. So we must be careful. And this one, as you can see, the spacing is based on the recommendation of the manufacturer. So based on that, they will install them, and for how long and all this stuff, those are very important information that you have to pick from the catalog of those devices to use. Another thing I want to show you guys is concrete sampling. Whenever we pour concrete, we have to take sample to make sure that the concrete was based on what we want in the design. So if we ask for 4,000, is that 4,000 psi concrete or not? Or the slump? Slump is if they add a lot of water, that's not good. The concrete cannot reach the space, and we will get a lot of void, and we will get a lot of cracks. So those are things that we have to check. The temperature is very important. So what kind of temperature of the concrete at the time of placement is what? Actually cylinders is most common, is 1 foot by 6 inches diameter, 6 inch, 1 foot tall. So this cylinder is 6 inches and 1 foot tall. And there is another one like a cube actually method. There is a conversion between these two. You can convert this to this one. So if you want, you can check that in reinforced concrete design books, or check Google it, you can find it. But most of the time we are using these cylinders for concrete strength. So how can we take the sample? Taking sample is very important. Part of the concrete. No, because maybe the concrete must be good representative for the concrete placement. So if at very start maybe it's a little wet, at very end maybe it's very, very dry. So at the middle of the mixed rock, that's the best way. So and if you have, for example, 6 trucks of the concrete pour, not from the first, not from the last, maybe at the middle is better to take. You have to take 2 different trucks samples. So the second one and the fourth one, if you have 6 trucks, for example. Sometimes the concrete pour is huge, about, for example, 60 or 70 trucks, we have concrete. So 600, sometimes double of that. Yeah, we have double of that for one shift concrete placement. So you have to take a lot of samples. So at which one the inspector will give them, I want concrete from this truck, but not that start of that truck, at the middle of that truck. Then they will share, they are using their chute, they put concrete for that material guy in that wheelbarrow, and then with the wheelbarrow, he is going to do a lot of tests, including taking samples for that test. And how they have to take it, with the scoop or something, they are pouring 1/3 of this. They shouldn't pour this and a half on top. No, 1/3. Then with this rod, they have to actually tap in 25 times in different locations, like vibrations. Yeah, it will act like a vibration. That's based on the ACI code or based on Caltrans code. And then the second, third part, means second part up to here, then do 25 more, and then the last part, do the last part and on the top, and then make it completely smooth. Yeah, put cap and put it in some place with no movement. If it's not flat and you will get bad surface, the answers should be bad, and we had a very bad result sometimes in the test that your friends did on the lab hours that we had no COVID-19. And on each part, you can see white parts. They have to write ahead of time before they place concrete, the date, location that they are pouring, what element, and a lot of important information that you need. They have to write down on this one. Then they can find that this sample is from this. Otherwise, at one night they have concrete for footing, for the slab, for columns, and each one should be representative for each element. And because of that, all those must be at what station, what element, what elevation, all those important information, they have to write it down, then fill it, and then cap it, and just put it someplace like this. After 1 day, they have to remove the cap and remove that plastic cylinder and put that inside the water. Most of the time they put that with the cylinder, just they remove the cap because the water can get in and it should be wet for 7 days. Yeah, that's the method. Another test that they are doing in the field to find the percentage of the air inside the concrete. They have instrument from that wheelbarrow, they put some concrete here and they do the test, and then they will report the results to us, to the designer. And another thing is a slump. A slump, they are, look at this. This is the cone, kind of cone that they install like this. They fill it with the concrete from top, make it smooth without any, actually this, they don't need to rod this anymore for this. That's just for these cylinders. For here, just place concrete inside and then remove this, put this backward and put that straight bar on top, measure it down. So if it's very wet, it will go down. If it's very dry, it will stay here. So the slump, we as a designer, we give them the slump. Most of the time, about 2.5 to 3 inches is good. And sometimes they are adding too much water, and the inspector, after seeing this, can reject that. And then finding the temperature of the concrete before the concrete pour is important too, that they are doing in the field. After the concrete reaches to a strength that the designer asks, if they wanted to remove the forms, the contractor likes to remove the forms after 3 days. So they ask, we want to break concrete at the 3 days. The designer will give them a chart. You can remove the forms at 3 days if the concrete reaches to 70% or 80% of the required strength. Okay, after 3 days, they are removing that from the water. They will put this on this jack, and they will put this under compression until it breaks. And then based on that, they will get a chart. And based on that chart, they can actually find the strength of that concrete for 3 days. They will report that. If the designer see it's acceptable, they will let they remove the forms. Otherwise, the forms will stay, and they will ask after 7 days. And then we need to know after 28 days, if after 28 days it couldn't reach to the strength that the designer asked. So they have to have one extra actually cylinder just for sometimes like that, that the strength will not reach to the results. So when they break the that reserve one, and if they pass that, it's acceptable. If it's not passed, so maybe they have to go to the field and they core and find if the concrete is not that good. Sometimes if the concrete is very bad, maybe they have to demolish the concrete. Sometimes it's not that bad, but it's not that good based on the design. Then the actually the owner will give a percentage deduction to the pay to the contractor. They will reduce payment because of that strength reduction. So those are the methods that if you work in the field, for sure you will learn, or if you are working in the office, you will learn as well. That's the finite element model for the concrete under cylinder under this pressure. You can see the pressure, that's the maximum and the minimum. As you can see, the maximum is here. And because of that, you will get kind of increasing the diameter at the middle, yeah, because of this huge pressure on top, and reduce the diameter somewhere around it. That's the model, finite element model, that we don't need that much in this case. Another operation is finishing operation. Most of the time for the surface, and they are using, this guy must be very expert to use this system. This bar will rotate to that side or this side, and it will change the degree of this plate. So when it's pull it back and push it that far, he should be expert to know at what it should pull this down or pull it up this side to make it completely smooth. For a small apartment, they have existing concrete this side, existing concrete that side, and they are filling between those two. They are using this straight edge. Yeah, and at the end, they are using something like that to make it smooth. With a straight edge, they are removing the extra concrete, or they are adding some concrete to those spots that it doesn't have enough concrete. And this guy should do that with this, and somebody help him to actually add some concrete somewhere, and he must remove that by this extra concrete. So it's hard work, very hard work. These are finishing operations. Another finishing operation, as you can see, they are doing that with machine. Some of the machines has 3 of these, and the operator will sit on top. So it's like driving a car. And at the end, you will get very smooth surface with this kind of the sidewalk operation. As you can see, he has some tools to actually make this line here for crack. The crack will not be spreaded everywhere. After few actually feet, they are making a weak location because the thickness here is less because they made this cut here. It's not all the way to the bottom. It's almost halfway or something. So it's weaker zone than here, that side. If the concrete is going to get cracked, will go to this part. So the rest of the concrete will stay with minimum or less or without cracks. But if you forgot to install this, you will get crack everywhere. So that's important for finishing operation that you will learn when you go to the field they're doing in front of you. Another one is a class 1 finish. When you have a retaining wall or surface that everybody can see that based on the Caltrans they want, they call that class 1 finish. They want that smooth with no holes like this. How to fix that? Those have different operations, and some of them is not that good, and they can make it perfect. You see, wow, it's beautiful. After one rain, you will lose everything, and everything is very ugly and bad. So those are the tricks that the inspector in the field must know. And if they ask, okay, we are going to do this for class 1 finish, they say, no, it's not acceptable, or yes, acceptable. So these are the slangs or the name that you need to know. Finishing operation, class 1 finish, what surface will get what. And I think that's good enough for tonight. Okay, I'm done. If you have any question, please ask. Any question?
I had a question, Professor.
Yes.
After we got our test number 1 back, you said that it was possible that you would reduce what that test is worth and
Yep.
add and increase test 2 and 3.
That's correct.
Is that's still a thing? Is they gonna do that?
Yes.
Okay.
If you got a very good grade in the second one, not that good grade in the first one, yes, I will change the percentage. But for these two, if you got bad in the first one, bad in the second one, the chance for the third one is not that good, because if I increase percentage for one of those, it's not going to change that much.
Okay.
But if the first one was bad, the second one was good, and third one is much better, for sure I'm going to help that student.
Okay. But there's no percentage change fixed?
No.
Okay.
No, I'm look at this. If I see your progress, I'm going to help you guys. I'm your friend. I'm not your enemy. If I think you need to redo these